Well, welcome back everyone. And so in this video, we're going to break out of the single file environment that we've been stuck in so far and look at how we can write our program such that we're splitting up code across multiple files. Now, in the real world, systems are complicated and that you have software being built by teams of individuals. And what you really want to be doing is be working towards writing code that's reusable. And it takes practice, it takes time to learn how to do this properly. All right, we're trying to get in good habits very early as you start learning this material. Okay, so effectively what we're going to be doing is we're building our own library. We've used libraries created by other people. Right? A lot of the standard libraries, string library, Boolean library, math library, okay? But you could also build your own, okay? And what we're trying to do is build code that's reusable, right? We want to be using like an analogy here, these reusable shopping bags as we're writing our code. We're writing the code once, we're putting in the hard effort, we're putting in the resources, we're doing it, we're building it. And that we don't have to just build something once for one little purpose and then throw it away. Okay. Now, as a student, right? Usually in academia, you're really doing this. You're building code one time. You're doing it for an assignment. You build it. It's kind of custom. It's special purpose, and then you kind of toss it when you're done with the assignment. But in the real world, you're trying to build things that you can reuse over and over and over again by building these little blocks of logic that are doing a certain purpose that you can kind of use repeatedly throughout your system. Okay, so we'll do an example. All right, I'm going to do an example of doing this, and there's one reason is in terms of code reusability, and the other reason is the fact that code also gets long, right? If you're stuck with one file, you could have a file that has thousands, maybe even millions of lines of programming logic, and that's crazy to keep track of, right? So we want to keep things organized, right? If you can keep it organized, you're going to be able to solve problems easier, you're going to be able to make changes easier, and you're going to be able to make your code reusable. Okay, so here's a mindset going into this video, okay? The mindset is we're going to assume that the string library doesn't exist, okay? So we're not going to use this. We're not going to use this string library here. Okay, we're going to assume it doesn't exist, and we're going to build one that contains just a couple functions as examples. Okay, we're going to build our own little string library. Okay, and so we're going to see how this works. And we're going to do this. We're going to have 3 files. Okay, 3 files in this to make this happen, to make this work. Okay, all right. So we're going to have one file is the most standard, is very similar to what we've seen thus far. Okay, we're going to have kind of what I'm going to call the main.c file. Okay, and what this file is going to do, the purpose of this file is going to be to test and drive the string library. Okay, by drive I mean it's like, if you have if you've got a function, like we're going to build a string length function, or we're going to build a string equals function, and drive is like, we're really testing it. We're making sure the library is doing what it's supposed to. We're calling things with some different inputs and making sure things are kind of working properly. Okay. However, it's not going to contain any of those string functions. Okay, just like when you include the string library from from the one that was built for you, you're not actually including the functions in that main.c. Okay, what we're going to do is we're going to have a different function, different file. I'm going to call it, how about we call it my string library, or lib. Okay, and this is going to contain the functions, okay, the string functions. And I'm going to go one step further and say it's the string function or functions, their implementation, okay? Implementation, it's the functions themselves. It's the source code that does it, right? That does the logic, that does the work. Okay? Now, you might say, well, why do I need anything else? Okay, I need one more file that we haven't seen before, okay? And I'm going to create, and we're going to have a file called myString lib, same name, but .h. Now this .h stands for header. It's a header file, right? It's a header file. Well, what we're going to include in there is the function headers. This is the interface. Of the library. Okay. It includes, right, the library function headers. Okay. The reason we do this is that these two files, okay, need to agree on the same interface. They need to agree on the same interface. Okay? Because remember, right, we looked at functions prior in a prior video. When we introduced functions, we talked about what are functions, right? And we said the only thing we should need to know to use a function is what comes in, what are the input parameters, what are the inputs, okay, right? Effectively, we also need to know the function name, okay? And then we need to know the outputs, okay? So it's three pieces of information, right? Input parameters, right? Inputs. More specifically, it's the data types of the inputs. Okay. The output, the return type. Okay. And the function name. That's what defines the function header. Okay. And these files need to agree on it. The main.c and the string library, they need to be referring to the same thing so that another file outside the library can use the library correctly. All right. If there's a mismatch between them, right? If they didn't agree on the same interface, you wouldn't be able to use it correctly. And this is kind of a rough analogy, but like it's effectively the interfaces you're defining a standard. So like, for instance, I'm communicating to you using English language, right, as the standard. That's kind of in a sense, and if we're kind of in agreement that we can kind of use that way of communicating to share information, right, that's you think of that as our interface. And if we didn't have agreement on that, if we were using different languages, you wouldn't be able to communicate or work together. And that's kind of a rough analogy of what's going on here. Okay, the inputs and outputs need to match. Okay. So let me show you an example. And actually, before we go to this, let me pull up this example here. Okay. I'm going to show you how we could go ahead and do this. And let me show you what the code that I currently have here is doing. Okay. So I've got just two functions written. Okay. Here is a function, and I don't really care too much about the details of how it works in this video, but effectively it determines the length of a string. Okay. We're looking for the null terminator. We're counting how many characters there are till we hit the null terminator, and we're returning that. Okay. Here's another function that compares two strings. Okay. And determines that if they're equal or not, returns a Boolean. Okay. And how it's working is that if first it checks the length, it actually uses this previous function, checks the length. If the lengths don't match, it's immediately not the same, right? Right? If I have two strings and they have different lengths, they're not identical, so you can immediately quit. Otherwise, we know the strings have the same length, so I could loop each character one at a time because length 1 is equal to length 2. And I check each character, and if any point if either one of the characters, if the characters don't match at anywhere along the string, I say false, right? Okay, if we've done all that and we hadn't returned, then the strings are equal, we return true. Okay, so that's what they're doing. Those details don't really matter that much for what we're focused on now. And right now I've got everything in this one file. Okay, I've got everything in this main .c file. Okay. Now let's look at the main function. Okay. And what it's doing is it's just driving and testing those functions that they work correctly. Like if I run this program, that's probably the best way to see how this what main is doing. Okay. So main here, just entering two strings. And for example, let's do two strings that are equal. Okay. It says, oh, both strings are equal to 5. The length and and that says that they're equal, right? If I did two strings that are not equal, okay, so that they're not equal, and they could be two strings that are the same length, right? But are different, but don't match, right? So the strings are not equal, right? But the lengths are the same. So that's what the main is, just testing it, right? It's driving the library. That's what we're using it for now. So actually, we haven't created the library yet. And what I'm going to do is let's look at how we can create our first. If we go over here, okay, I'm doing everything in this kind of test sandbox project. I have this folder, source files, and I have main.c. I'm going to create a new C source file, okay? And I'm going to call this my string lib, okay? And all I'm going to do for this file here is I'm going to take these functions. I'm going to take these functions out of main. I'm going to cut them. I'm going to paste them in here. Okay, now notice I'm getting an error right here. I also need whatever libraries I'm using, right? So especially, I'm going to put the libraries in here too. We're using some standard libraries here, okay? So that this file also has access to them. Now, there's a problem right now, right? Now keep in mind, so I've got these two files. I've got the main function here. I've got my string library that we're building here, okay? And in the project, I've got these two source files, okay? Let's see what happens when I try to compile this. Okay. And I got this problem that came up, okay, where it's complaining effectively. If you look at what's listed here as a warning, okay, it's saying, hey, what is this get length? It's effectively saying is, what is this get length function, right? And what is this is equal function? So the compiler, right, we want to pay attention to these warnings. It's saying, hey, I don't know what these are, right? So this is an issue. So how do we fix that issue? How do we fix it? And what we want to do is we want to come over here, right, to where we see header files, okay, and we're going to create our first C header file, okay, and I'm going to name this the same name as the source file, my string lib, okay, my string lib. Okay. Now, in my NetBeans environment, I get a whole bunch of stuff that's added for me intentionally. I'm going to get rid of these things that refer to C++, which is a different language. I'm going to keep this here. I will come back to this, what these are. All right, just ignore them for now. And what I'm going to include here, all right, is the function headers. All right. So I've got only two functions right now, the get length, okay, and this is equal header. I'm putting the headers here, okay. Now what I need to do, though, is I need a way of connecting these headers to these subsequent files here, main and my string lib, okay. So I need to come over here and include my string lib.h. Okay, what that's saying is we're going to include these headers here, okay, for this file. All right, I'll talk a little bit more momentarily of how that works. Okay, and we want to do the same thing with the myString library. Okay. That's enforcing that they're using the same interface, that they're agreeing to the same interface. Okay. Now notice there is a difference here. This system libraries have these using this different syntax. They have this less than, greater than symbols. Okay. Our libraries that we're creating use double quotes, right? That's helping the compiler find where the files are, right? From whether they're system libraries that have been previously installed, or if these are libraries that are in your current project, okay? It's helping the compiler find them, okay? So effectively, if you're creating multiple files, right, you're gonna do it in such a way that you're including double quotes to make that happen, okay? So to include it in there. So now when I compile this, right, we're going to be able to get rid of that. We compile it. We got rid of that error. Okay. Or the warnings that came up. And this has one additional benefit. Let's imagine that I made some sort of mistake. That main calls the function incorrectly, for example. Okay. Like forget, I'm gonna make this not compile, right? I forget to include the parameter for get length. Okay. I'm now violating the interface for how that function is supposed to work, and I get a compile error. Okay. So this is a situation where you want that error. You want that error. You want it to tell you there's an error, right? And it's making sure that you are indeed using the same interface that what the library has defined. Okay. So effectively, well, how do we want to approach this? The goal here, right, when you're creating multiple files and splitting out into multiple files is think of the interface first. Okay. Think of the interface first. What do you want the function to do, right? How can you design a beautiful interface, okay, so that it makes it very simple and easy to use, as well as making it easier to be reusable, right? So making the code reusable, if you make it clean, if you make the interface very intuitive, right? You're going to make it easy to use these functions, remember what they do, to document them easily, and so forth. Okay. And then you're going to have the implementation details. You're hiding them, right? You're isolating them into a file. You build it once. You kind of isolate maybe some of the logic that can kind of get into the weeds and might have the ugly details. Okay. But somebody using this library now no longer needs to know these ugly details. You've hid them, right? They just need to know the interface. Okay. So the common theme in computing is we're separating implementation from the interface. Okay. All right. And remember, we need to include the header file at the top of anywhere that we're using it, right? Including the source file for that library. All right. All right. One thing that's going on, let me just kind of mention one thing here. I guess it's probably easiest to draw on this this slide, is what effectively happens when we do this include my string lib, right? When we're doing this include my string lib, is we take these function headers, okay, and this line here, when there's a pre-process that occurs, we call the preprocessor. It's an early stage in terms of the compiler process, and the details I'm not so concerned about in this class. But what happens when we run through that, the compiler, one of the first things that happens is that this line's replaced, and literally what's going on internally in your computer is those function headers are copied here. Right? The function headers are copied here. Okay. So another way to look at that is that if what you could think about, right, is when the compiler first runs, right, this pre-processing step, and actually you can identify the pre-processing step of things that it's replacing, or where you have these pound symbols, is this line here, my string lib, gets replaced with this. Okay. This here is going to get replaced with that. Okay, internally. And then same here, that line gets replaced with this. So the function headers, right, are defined in one place and then copied internally wherever they're needed. Right. This way you don't have to, that makes it easier for you building these systems. You don't have to maintain this stuff across multiple files. Okay. Just one other thing I want to point out before we wrap this up. Okay. Is I would like to talk a little bit about, we saw some weird symbols in the header files, right? These are called header guards. Okay. Effectively what they're there for, right? We saw them here, right? It's got the name of the file, okay, all uppercase, and the dot is replaced with an underscore. And then we have this endif too. What that's designed to do is to prevent you from having multiple functions. Like if you include a lot of libraries, right? You include a lot of libraries, and libraries themselves can include other libraries. And you can have a situation where it's ambiguous to know which, like you can have multiple functions that have the same name, right? Or be the same function added multiple times. Without getting too far into the weeds, what the header guards are doing is preventing you from having these conflicts where you have multiple functions with the same name trying to be included repeatedly, which is actually quite easy to happen when you have a whole lot of libraries being included within your code, within these different libraries. So they're a good thing to have, and they avoid some really nasty kind of errors that can come up that are super hard to troubleshoot, right? So the general rule is include them, right? Just, you don't have to memorize it. You just look at the syntax of how it's built and have an example and kind of go off of that, right? And just, keeping in mind what you're doing here is preventing the same function from being added multiple times. And so kind of an example here, this is like a really rough example, is, imagining a scenario where, let's see, say you've got a square library, okay, and they have a geometry library, right? And you include both of them here, right? So here's the thing: is you've got this library square, or this header file square, and then this header file geometry. And notice geometry includes square, right? So you have this square would be included twice, right, in your main if you did this, right? But you don't necessarily want to care about all that stuff, right? So a common issue would be you might have this function included twice, right? One from the square library and one through the geometry library that's also including the square library, all right? And that will actually cause an error to have the same function included twice, right? So the simple way of fixing that is you just use these header guards, okay? The header guards will prevent that from happening. They'll include it once, right? And it will omit or skip the second time that it's defined, okay? Now, I don't really, we're kind of got in the weeds a little bit with that, right? I in an intro class, I don't really care much about whether or not you really have a full understanding of header guards and all of that process. But these errors can come, like the thing is they can come up, right? They do come up. I would just say you use them, you avoid a lot of problems, okay? And it makes your life a lot easier. Okay, so with that being said, we'll close out this this video, and we'll practice in some subsequent steps here later on to be able to make sure that you've got some hands-on practice building these things, which is always the best way to learn and the best way to remember the material.